In this nugget, we're going to take a look at building a simple scenario, enabling CDP, and then putting CDP under the microscope with Wireshark. Let's begin. Cisco Discovery Protocol is like the secret handshake for Cisco devices. By default, many interfaces on Cisco devices will send out these little messages every 60 seconds because they're so proud of what they have. For example, they can carry information about their device ID, for example, R1 or R2 or switch 5, the version of software they're running, the capabilities, an address that's in use on that system, what port they're using to send this CDP message out of, details regarding duplex for the link, and for environments that have trunking configured, CDP can also carry VTP and native VLAN information as well. And this isn't even the full list. When a CDP message is sent from a Cisco device, it's going to go ahead and send it to the destination layer 2 address on Ethernet of 01000C and then the rest Cs. And another Cisco device on the other side of that link, if it receives a frame destined to that MAC address, it's going to de-encapsulate that frame to take a look at whatever that payload is that's being carried in that datagram that's being sent. Because this destination address is not just used by CDP, it's used by some other protocols in a Cisco environment as well. So what you and I get to do is we're going to lab up a simple topology with 2 routers. We'll tweak a few CDP parameters just for good measure. And then we get to capture and then analyze that data using Wireshark. So in GNS3, we're going to open up a new project. I'm going to call it Untitled. Click OK. It says, hey, you've already got a project called Untitled. That's perfectly fine. This is going to be such a small topology, we don't even need to save it. Let's bring a couple routers out. We'll bring out router 1, and we'll bring out his good buddy, router 2. We'll create a network connection between them using this link tool. We'll go from R1's Ethernet 1/0 over to R2's Ethernet 1/0. We'll deselect the link tool, and we'll go ahead and click on the label tool so we can go ahead and see the labels on each of those interfaces. And then we'll click on the Go button to start those routers. And then we can open up consoles to both of these routers, either doing it individually from the drop-down or clicking on the Open Consoles button. So we'll start by going into configuration mode on R1. And if we wanted to disable CDP, it is enabled on most Cisco iOS routers and switches by default, but if we wanted to turn it off from global config, we'd use the command no CDP run, and that turns it off globally on this device. And to turn it back on, we'd use the command CDP run. The default timer on many Ethernet interfaces is 60 seconds as far as how often CDP messages are going to be sent. If we want to change that, we can use the command CDP timer 10. And now, on this system, the timer interval will be 10 seconds. We can also advertise a hold time. And the hold time is the amount of time in seconds that a receiving device, for example, we're on R1, so this is referring to R2, how long R2 is going to wait without receiving any other updates from R1 before R2 will consider R1 no longer a CDP neighbor, and then remove R1 from R2's CDP table. If we go into interface configuration for Ethernet 1/0, we could disable CDP on a specific interface with the command no CDP enable. And that would stop this interface from sending CDP messages as well as paying attention to CDP messages that are coming in on this interface. And to re-enable it, of course, we do the CDP enable command to enable it on this interface. So let's bring this interface up with a no shutdown command. And now that it's up, let's give it an IP address of 10.0.0.1 with a 24-bit mask. Next, we're going to specify the MAC address for this interface. This is not a required step because every Ethernet interface has a MAC address. However, I'm going to customize this MAC address on this interface so that when you and I look at this inside of the capture in Wireshark, when we see the last 6 hex characters as ones, we'll know that's R1's interface. I've also manipulated the first 6 hex characters of this MAC address and assigned it a MAC address that's been given to Cisco systems. And that way, in our Wireshark capture, it'll reflect Cisco as the vendor name associated with that MAC address. Again, not a critical step, but it's a nice one, especially if we're doing packet captures. And then we'll exit out of configuration mode. We'll make a road trip over to R2, and on R2, let's go into configuration mode, and let's go into interface Ethernet 1/0, and we'll do a no shutdown to bring that interface up. And here on this interface, let's also give it an IP address. We'll also specify a MAC address that ends in a set of 2s. Again, with that first 6 characters of hex representing a MAC address that's been assigned to Cisco for the benefit of our packet capture. To verify our settings with CDP, if we go back to R1 just for a moment, we can do a show CDP right here from privilege mode. And this is reflecting the timers that we set. We can look at a specific interface with the show CDP interface and then the interface Ethernet 1/0. And this would confirm a couple of things. Number one, CDP is enabled on this interface. along with the intervals for sending CDP messages as well as the hold time. Another fun one is the command of show CDP traffic. And that's showing us that we've output 33 CDP messages and we've received only 5. And that's because the other side, R2, is using the defaults. It's sending CDP messages every 60 seconds by default, and we're sending them every 10 seconds based on our configuration. And of course, we can use the show CDP neighbor command to see which CDP directly connected neighbors are out there. And we can use the command show CDP entry and then put in the name of R2. So show CDP entry R2, press enter. And that will show us all of the details regarding that specific CDP neighbor. And all of this information is being advertised courtesy of CDP. Next, let's capture some of this traffic so we can look at it together using Wireshark. And to do that, we're going to right-click on this link between R1 and R2. We'll start the capture, click on OK. And now our packet capture is collecting all this information. And that should be enough. We have the CDP messages being sent every 10 seconds from R1. So we'll click on Stop. And let's go ahead and pick on packet number 9. If we look at the layer 2 information, here we have the source address being R1 source address on his Ethernet interface, and the destination MAC address is the 01000C and all Cs. And that's the specific destination address that's used when we're sending CDP messages. And if we look at this portion, it indicates that this is an IEEE 802.3 header. So this is not our standard type of Ethernet 2 frame. It's kind of a throwback to the good old days. And it is still being used by CDP today. And then if we expand the payload portion, here we can see the details. In this case, because we're on frame number 9, which is coming from R1 based on this MAC address, we can see the contents of what's being sent as part of these CDP messages. So here we have the version 2 by default. There's the TTL of 61 seconds. That means R2. If 61 seconds goes by and it hasn't seen another CDP message from R1, it will drop it from the CDP table. And so if we expand any one of these, for example, the addresses, there's 10001. And if we go to the management address, it's also saying 10001. And if we expand the capabilities, it has the details regarding the capabilities of this device. In this nugget, we identified some details that can be shared via CDP with directly connected CDP neighbors. We set up a simple environment with 2 routers running CDP. We tweaked a few of the values, and then we ran a packet capture so that we could analyze the details of exactly what was being sent back and forth via CDP. I have had a great time in this nugget. I'm so glad you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.